So in this video we're going to find out how to work out these missing angles within these right angle triangles. So we know two sides, we don't know an angle. So and here's three scenarios. So here's how we go about it. Well, we need to recognize that it's trigonometry. The question involves finding an angle, so it's trigonometry rather than Pythagoras. So the first thing we need to do is to remember the three trigonometry formulas. So I remember this by silly old Hitler caused awful havoc to our armies. So sin is opposite over hypotenuse, cosine adjacent over hypotenuse, tan is opposite over adjacent. Now depending on what exam you're doing, you may or you may not be given these ratios, so I'm working on the basis that you do need to learn them. So this is how we go about them, and I think we'll do all three simultaneously so you can sort of get the flow. So picture yourself sitting at the angle. So you're sitting here for this question, you're sitting here for this question, and you're sitting here for this one. Now go and label up the sides, so the two sides that you know. So with me sitting here, that side is opposite me, and that is the hypotenuse. There we go, H written down there. Over here I'm sitting here, so this is adjacent to me, and this is the hypotenuse. And with this one here, that side and that side is adjacent to me. Remember, adjacent just means next to you. So here we've ticked O and H. Now O and H means we've got to find use sin. With this one we've ticked A and H, so we're going to use cosine. And with this one we've ticked O and A, so we're going to use tan. Now following the choice of ratio, that always comes the angle. Now obviously in these cases we don't know the angle, so that's our unknown x. And that equals something. Now the ratio of what it equals, you've got to follow, you've got to get it the right way around. This has to be opposite divided by your hypotenuse, so your 4 divided by your 7. Similar here, this has to be the adjacent divided by the hypotenuse, so 3 over the 5. And over here it's got to be your opposite divided by your adjacent, so you're 8 over 5. So let's just go over that again. That is your opposite over your hypotenuse. Whoops. Over your hypotenuse. Just get rid of that. Over your hypotenuse. This is your adjacent over your hypotenuse. And this is your opposite over your adjacent. So make sure you get those all the right way around. Now the next thing you do, really we need to, it's a bit of algebra now. How do we undo a sin? We inverse sin. How do we undo a cos? We inverse cos, and so on. So basically this needs to be rewritten as x equals inverse sin, 4 over 7. This has to be written as x equals inverse cos, 3 over 5. And this one has to be inverse x equals inverse tan 8 over 5. Now you can just think of it as the undoing process. So how do you make x the subject? You have to undo a sin by inversing sin, or what lots of people do, they just remember that when you're working out an angle it's always the inverse one. It's always the inverse one. Right, we can now go over to our calculators for each of these. So here we go. It should work. First time I tried to do this on this. So we go shift sin, and then it's 4 over 7. Now I suggest you just use that button there, the fractions button. So it's 4 over the 7. Close bracket, and we press equals, and we get 34.849. So here we go, 34.849 dot dot dot. Now with this one we're going to go, it's an inverse cos, so we give shift cos. Again I would suggest you use that fractions button, 3 over the 5. Whoops. Let's do that again, shift cos, and then 3 over the 5, move across before I close the bracket. And that gives me 53.130 So 53.130 dot dot dot, and this one here, shift tan 8 over the 5, and that is 57.99. Now the question will go and ask you to a suitable degree of accuracy. So let's assume all of these said to 1 decimal place. So this one would be 34.8 degrees. This one would be 53.1. And this one a bit more complicated actually, because we're having to keep carrying the naught. So that's actually going to be 58.0 to 1 decimal place. And there we go. That's all we have to do.